Okay, so this is obviously going to be using that daily compounding table on page 472. Or you can do it with the formula. We'll do it both ways. So we're going to start out with the $7,300 divided by 100. So 73 is what we're going to be using here. We do have the 5 1/4 on top. And we're going to 2 years is actually going to be using the 730 on the side, which gives us what? 11.07022. So we take the 73 times 11.07022. So 808.13. That is, remember, the interest. We have to add that back to the 7,300. Get $8,108.13. How many of you had that? How many of you used the formula instead of the table? Okay. 7,300 times. Yeah, I know. I'm not a big fan of the table either. 0.0525 divided by 365 to the power of 730. Where'd 730 come from? 2 times 365. Like I said, I've found through the years most students actually do prefer the formula. So that is future value and present value of compounded amounts, of compound interest. But wait, there's more. Just like, if you recall, when we did our simple discount notes, there was the stated rate and then there was an effective rate that was slightly higher because we didn't get the full amount. We're going to have to do an effective rate here as well. Because it's compounded more than one time a year, the effective interest rate is higher than that stated rate. So when we're looking for an effective rate, we have two possibilities. One, time is less than 1 year. And if that is the case, we use the actual time. Or the second possibility, time is more than 1 year. If that's the case, we use 1 year.
Hey, Todd?
Yes?
With the effective rate, does that ever work in your favor with the bank, or is it always that you're going to pay that higher interest on whatever credit card or whatever? Does the bank ever give you the higher amount?
Well, when you're putting money into a CD, if it's compounded monthly, yeah, you're going to be getting the higher amount. But the effective rate will always be at or higher than the stated rate. So let's take a look at this.
Oh, don't scroll up.
You want me to go back down? Need any of that yet?
Sorry.
Okay. Find the effective rate on $7,000 invested at 9% compounded monthly for 8 months. First question we need to ask, is this more or less than 1 year? Less than 1 year. So we're going to use actual time. What that means is we're going to find the future value. We could consider that step 2 if we wanted to. Our future value is going to be the 7,000 times 1 plus what? 0.09 divided by, now be careful here, 12. Good, it is compounded monthly. So we're dividing by 12 to the power of 8 months. Good, 8. That's the biggest mistake, is a lot of people want to put 8 in here because it's only for 8 months, but it's still compounded monthly. We divide by 12. So we're going to find out this future value, 7,000 times 1 plus 0.09 divided by 12 to the power of 8. 74, 31, 19. Why does that seem a little... Oh, that's just about right, I guess. So that is my future value. Next, find the compound interest. How would I find the amount of compounded interest here? Take that future value, and what do I do to it? I subtract the amount invested. I started out with 7,000, and now I'm at 7,431. I subtract. So the amount of interest, or the compound interest, is $431.19. Step 4, we use the simple interest formula to find the effective rate. So we're going to use I equals PRT. So the amount of interest is that compound interest, $431.19. What's my principal? That's just my present value, is my principal. What's my rate? Trick question, that's what I'm looking for. What's my time? 8 months, so 8/12. So I don't want to put equals there. Now I'm going to solve this for R. And this is one where we talked about before keeping it in the calculator. This is one where that is going to be a big deal. So I'm going to start out by combining 7,000 times 8/12. 7,000 times 8 divided by 12 is going to be 4,666.66666666666. 4,666.67 times R. But again, we're keeping it in the calculator. I'm not clearing the calculator. I don't want to punch that back in, because if I punch it back in, it's going to be rounded off. So now I'm going to divide by that 4,666.67 on both sides. So over here, 431.19 divided by second answer. Telling the calculator to use that previous answer. I get 0.0. Now again, I should go to at least 5 decimal places here. 0.09240, I guess I'd be going to. Equals my rate. So now if I want this to the nearest 100th percent, I first make it a percent, 9.240%. So that's 9.24%. So you're going to take 431.19 divided by second, then ANS, and equals. .24%. So even though they stated a rate of 9%, the effective rate was 9.24. Let's try another example. Find the effective rate for 7.3%. Let's try that again. Find the effective rate for $9,000 invested at 7.3% compounded quarterly for 72 years. I'm making a point here.
I know that.
So again, our first step is to ask the question, more or less than 1 year? More. In other words, we're going to use 1 year as our time. That affects us in steps 2 and step 4. So in step 2, finding the future value. The future value is going to be 9,000 times, parentheses, then what? 1 plus 0.073, and then? Divided by 4 because it's quarterly. And then? Power of 4. Because we use 1 year. Because it's more than a year, we use 1 year for our time.
So
The 72 will never come into play.
never.
Not in this, not for an effective rate, no. Because we only go up to 1 year. So I said I was making a point with that 72. Anything over 1 year, we're going to treat it as 1 year.
So what if somebody really wanted to know their 72 years? That's not a...
Oh, effective rate really can't go past 1 year anyway, because it's an effective rate per year.
So the only way that the exponent of 4 would change is compounded monthly, then it would be 12 instead of the 4?
Yes.
Okay.
So at the end of 1 year, it's 9,675.21. What's step 3? Yeah, find the amount of compound interest. You're thinking step 4.
Oh, sorry.
That's okay. Step 3 is to find the compound interest. That's 9,675.21, and then subtract the 9,000. So $675.21. And then I equals PRT. So our interest is $675.21 equals what?
96.75.
Nope, the original amount, 9,000.
Yeah.
And then we're looking for R. And then 1 year, 1. Since we're using 1 year as our time, that's 1. Which makes life really easy for us here. Because we combine the 9,000 with the 1 would be 9,000. So I'm not going to bother. So we're just going to divide by 9,000 here. So you get 0.07502 equals R. Let's say I want that to the nearest 0.1%. So I move my decimal point over, that's 7.502%, rounded to 7.5%. So even though it's stated as 7.3, it's actually paying 7.5% effective rate. Any questions? Okay. Why don't you guys try a couple? Find the effective rate for $15,240 invested at 12.7% compounded monthly for 6 years. I'll pause and give you guys a couple. Question 1. More or less than a year. It's more. So what does that mean? We treat it like a year. So part 2, future value. What do we put in here? $15,240. 1 plus 1.127. Divided by 12. So power of 12. Good. And for how much do we get for that future value?
17,292.21.
Do you guys concur? Perfect. So that's our future value. What's our next step? We're finding the compound interest. Good. So we're subtracting that. The 17,292.21 minus the 15,240, which is going to give us $2,052.21, correct? And then?
Then you're going to take the 2,052.21 equals the 15,240 times your rate, but that times 1. So basically you're doing all this extra stuff that you do divide, right?
Yeah, basically all we're going to do is divide by the 15,240. That's a good point. It is very important to go through these steps because in other problems, perhaps the next example, You might need them. So 0.13466. We turn that into a percent. 13.466%. Rounded to 100th is 13.47%. How many of you had 13.47? Any questions on how we got to that? Anybody want me to go back over any part of that one?
I didn't round the last number in the percentile to 5. I didn't round percent.
Oh, gotcha. Even at a 5, though, it would still round up to 467. Okay. So, how about find the effective rate on $8,920 invested at 9.2% compounded quarterly for 9 months. I'll pause and let you guys give that one a shot. So what's the first thing we need to do? More or less than a year. This is less. So what do we use? The actual time. So we're going to use the 9 months. Then what? We find the future value. How do we do that? 8,920 times 0.092, and then divide by 12. Is it divide by 12? It's compounded quarterly, so divide by 4. To the power of, here's the part I expected people to really struggle with. The power of 3. It is 4 times a year times 9/12 of the year. That works out to be 3 periods. $95, $49, $74. So, how many people are still with me? Okay. Well, still correct. Okay, I'm going to pause here for another minute or so and let you guys redo the rest of your calculation if you need to. So now our compound interest is going to be found by taking that 9549.74, subtracting the 8920, which is going to be $629.74. And then this to find our effective rate, I equals PRT. So 629.74 equals what's next? 8,920, and then times R, and then
times 9/12.
9/12, 3/4, however you want to express it. Yes. So here we do have to combine the 8920 times the 9/12. Which would be 6690. So there wasn't any round off problems there. And then we divide by the 6690. So 629.74 divided by the answer 0.09413.
So I was typing in, I was doing it with 8,000, not 8,920.
I was wondering if you'd.
And my answer still came out to be 0.941.
Yeah, that's what we had, but if you were in my math lab, you would get that stupid X.
So it comes out to be 9.41%. And actually, I'm glad you mentioned that because the next example I was going to do is going to address that. Find the effective rate for 8.2% compounded monthly for 11 years. What's the obvious question that you're going to ask me right now? What's the amount? The answer is it doesn't matter. That's why you were able to use 8,000 and it still worked out instead of 89.20.
Yeah.
The dollar amount does not matter. What matters is the percent, the compounded period, and the length of time. Now this is, of course, more than a year, so we're going to use 1 year. We don't have a dollar amount. We don't have a present value, so we get to pick one. I usually use $10,000. Now again, I haven't told you what to round off the percent, so we're going to assume we round to 1/100% in our final answer here. Why do I choose $10,000 instead of $100 or anything small? Well, the smaller the number you use, the greater any round off errors are going to affect your answer. So by using $10,000, I'm going to make those round off errors less likely they're going to have a big difference in my answer. $100 would work as well, but I'd have to keep, when I round it off to the penny for my interest, it can become a problem. So my future value, I'm going to take that $10,000 times 1 plus 0.082 divided by 12 to the power of 12. You got it. So there we go, 1,850 or 10,851.53. So that is our future value. Next, we want the compound interest. I'm going to write it out just to be uptight about it, but you could have just said $851.53, right? So I'm going to pause. I think I'm getting a little fast here. I'll let you catch up. So in our final step, $851.53 equals 10,000 times R times 1, because it was 1 year that we ended up using. So we just divide both sides here by 10,000. So I get 0.085153 is my rate. 8.5153% or 8.52 You can try that one with other dollar amounts if you like. You will come up with the same thing. There is a new quiz due tomorrow on Thursday at 11:59 p.m. This quiz is going to be on discounting notes and simple discount notes and effective rates of a simple discount note from last Wednesday. Then, of course, there's a new homework that is due for next week's Wednesday. You guys have suffered enough for the night, so have a good week. Yes, ma'am.
Did you say that we have like 5 weeks in class, but don't we have a quiz like in 3 weeks?
There's a quiz this week. There are 2 more quizzes left, and then a final test. The last test we'll take, I believe, on May 10th. So there will still be 1 class left after that. And I usually do that just in case we get a snow day or whatever. It also gives you guys a day where we can do your corrections together in class and maybe some extra credit. There's some problems that are more difficult than I would ever ask you on a test, but I want to do them, so we'll talk about them and we'll put them out there for extra credit that night. So you can earn additional points back. It won't hurt you if you're not here that night, but it could help you a lot to be here that night.
That last test, is that
Okay,
everything that
and the final test will be what we've gone over just.
The last test is actually just on these last 5 or 6 weeks.
Okay.